I'll have seats for you tomorrow, so I'll try my best to have those for you tomorrow. I don't always do seats in my upper levels, but with a class this big, we probably are going to need to. All right, rational functions. Who knows what rational means? What do I mean whenever I say rational? Tell me what you think. Give me another word. Starts with an F, but it's more than 4 letters, so don't say that word. Not function. That's in the, yeah. Try again, try again. Fraction, fraction. We're talking fractions when we talk about rational. Oh, I forgot. Everybody loves fractions, yes? We're going to talk about several things with these fractions. We're going to talk about simplifying, adding, subtracting, multiplying, and even dividing rational functions. I think we'll just simplify and multiply. All right. What things aren't working? You have to really zoom in because it's got that black background to it. No, it's there. Zoom. You got to really zoom in. Focus, all right? All right, fractions. We're talking about polynomials. What's a polynomial? One or more terms, right? This is when, if you rewind back to Algebra 2, we did all types of polynomials. We started with linear and quadratic, and we moved into cubics and quartics. Yeah. What's what? My room code? For what? Oh, Harris. Polynomial over polynomial. Okay. So we're looking at, instead of just normal fraction like you're probably used to dealing with, we have these nasty fractions, right? Things that don't look so nice and pretty. For example, maybe we have something like, now remember, all right, this is what a rational expression looks like, or a rational function. Okay. Now, we're not solving anything we can't solve if there's no equal sign, right? All right, so here's what I want to do. I'm going to simplify this first. We're going to start easy, right? We're going to start by simplifying. Now, let me just side note here. When you simplify a fraction, do y'all remember whenever we did polynomial long division and I came off to the side and I said, remember how you did it in like 3rd grade? We're going to do it. This is the same kind of thing. We're going to take a really easy concept and we're going to apply it to a kind of tough problem, okay? So whenever I simplify just a normal kind of fraction, maybe even just 15 over 20. You're dividing them both by a common multiple. That's exactly right. I can also think about it as this is 5 times 3. This is 5 times 4. The 5s cancel out, right? And I'm left with 3/4. Yes? Okay. I canceled those out, but that's because I'm multiplying. Remember, if I'm adding or subtracting, if this was 5 plus 3 over 5 plus 4, can I just cancel those 5s out there? No, it does not work like that. You cannot cancel whenever, so only whenever you're multiplying, and that's why that works, okay? Now if I throw some variables in there with it, let's say it was 15x squared y over 20x. Now how I take out a what? Say it again. A 5x this time, right? Because if it's in the top and the bottom, I can cancel them both, right? So then I'm left with 3xy over 4. Y'all remember all this? Okay. Rational functions take this even a step further. And that what if and I'm coming back to that problem, so don't leave it too far. What if I had this, and I asked you to simplify? Could you simplify? Yeah. What are you going to take out? What's going to cancel out? The x minus 1s, because still at the end of the day, this is multiplied, right? So I can take out this whole chunk. Did we get to this at all? And I felt like we did in one of the classes, but not in the other. Okay, that's okay. So this would simplify to x plus 3 over 2x plus 7. Can I cancel an x out since it's in the top and the bottom? No. I would kill a kitten if I did that. I can't do that. Anything I cancel out has to be multiplied. It's still up there. Because we don't kill kittens in here. Okay. The only time you can cancel out is if you are multiplying. Every plus or minus sign that you have, let's make a note. Every plus or minus must be in parentheses before canceling. Because that implies that I'm multiplying together. Otherwise, I'm in a situation like the cat poster. You can't just cancel those x squares out because they're in the top and bottom. Y'all see where I'm looking for? You can't cancel these out because the plus and minus are not completely close. We're not killing kittens in here. All right. Now, back to where we started. If I asked you to simplify this. Oh, I can't get, but you know what? But, several of you see things already. I see you looking and I see your wheels turning just a little bit. And some of you just go, no. Okay. What do you know? Who notices something that I could do? What you got, Chase? You're super close. Almost there. This is a special pattern. Do y'all remember the special patterns we learned? Your key, difference of cubes, your key to these is going to be your factoring skills. Okay, so let's rewind back for just a second. When we factor, we look for several things. The first thing we look for is a special pattern. There are several special patterns that we talked about in Algebra 2 extensively. I know it's been a while. For some of you, it's been, what, a year and a half? For some of you, not so long. But those special patterns that we talk about, we've got a difference of squares. So if you have two perfect squares, one thing I do in here is I start getting y'all kind of more used to like the variable forms, general forms of equations and things like that, instead of always examples and step by step by step by step. Get you thinking a little bit deeper. But if you have a difference of squares, you've got two perfect squares separated by a subtraction sign here. How does that factor? You do the square root of the first and the second, and then the opposite, 1 minus 1 plus. Does it work if it's a squared plus b squared? No, right? No, it only works. Well, that's okay because it works with cubes. That's why it's confusing. It doesn't work with squares, but it works with cubes. So I only have a difference of squares, but I have a sum and difference of cubes. And that's what makes it confusing to me. All right, that's the first special pattern. Since I went ahead and said sum or difference of cubes. What's a cube? Give me an example of a cube. Okay, not a geometric cube, but an algebraic cube. 125. What's a 27? That's what you said. 27, 64, right? 8 is a perfect cube. I'm looking for a number that multiplies by itself 3 times to give me that value, okay? That's a cube. So if I have 2 cubes, and this one can be plus or minus, it doesn't matter. Remember when we factored these, it was little parenthesis, big parenthesis, same, and then we changed this one. So I'm going to flip it up. This is change. Same change plus. Same change plus. Y'all are going to get there eventually. No. A and B go in the first parentheses. You remember it? You square the first, you square the last, in the middle, multiply them together. The flashback. All right. These were actually 2 different units because this came in unit 1 with quadratics, and then we moved into polynomials. So yeah, this was moving towards the end. All right, and then we also had a perfect square trinomial. This is where it had the square dance. Remember the square dance? All right. So this is where the 2 ends were both perfect squares. I'm going to do, again, the variable form here because I think that it makes it a little bit easier to see the big picture. So the 2 ends are perfect squares. The last sign is a plus. The first can be either a plus or minus. It doesn't matter. I do the square roots of the ends multiplied and doubled. 2ab. If that's the way it looks to start with, then to factor it, square root, multiplied together and doubled. So it's square, square, multiply and double. Yes, it did. It did. Yes. This also had to do with completing the square when we found a good C and we made it square dance if it didn't square dance before. All right, so to factor, it's going to be the square root of the first sign, square root of the last, and then we just square it. And if all that failed, in other words, I couldn't find a special pattern, then what could I, well, I'm not solving. You keep wanting to solve, jumping right ahead. But that's okay, that's all right. Then I'm going to try to factor, right? I'm going to try to factor it on my own, and that's where we grouped it. We multiplied the first and the last together, found the 2 numbers that multiply to that, but add to the middle, and then we slashed it. So the slashing was our last option here. If none of these, we try to slash. So the slashing thing was if I had if I need to factor this, it is no kind of special pattern whatsoever. I cannot factor it the way it's like I can't follow a pattern. So the first thing I do, I look for GCF to take out. Does this have a GCF? No. Then I want to multiply the first and the last together. 10x squared, yes? What two terms multiply to 10x squared but add to negative 7x? -2, -5. You probably remember me telling you also, both of them are negative to multiply to a positive, but they got to add to that negative in the middle. You probably remember me telling you, do not leave my Algebra 2 class not being able to factor, because that is the foundation you have to be able to factor. All right, so I've got 2x squared minus 5x minus 2x plus 5, and here's where I slash. GCS, you remember it now, don't you? What can I take out of the first two terms here? X. What's left? The middle sign stays. What can I take out of the last two? No, yeah. It's okay. It's okay. But if you can't take anything out, what do? A 1. Always a 1. That's exactly right. Good job. That's exactly right. Remember, if the middle sign is minus, we change that last sign. Yes? Hannah, you good? If the middle sign is minus, you change the last sign when you factor. So this would be 2x minus 5. Okay. Because you're taking something out. You're taking away. And you can't take a 2x away from 5. You have to be able to take it away from both of them. Oh, the order doesn't matter. Yeah, doesn't matter. Yes, because I'm not done yet. Because what I'm going to write it as is I'm going to take this one that's written twice. That's one of my factors. And then my other factor. So that's why you need the 1. Remember it? The first thing you remember? All right. So now we got, remember, all this was background I was giving you to get up to that rational function, right? All right, back up to this original problem. All right, so look, guys, focus. So as I look at this problem, my first thought is, can I simplify anything the way it sits right now? Can I just go ahead and mark anything out? Oh, sorry. Can I cross anything out here? No, not the way it sits right now. So I'm going to need to try to factor it so that I can get things that cancel out, because I do not want to kill kittens, yes? All right. Several of you already said, look at the top, it's a difference of cubes, and you're exactly right. So when I factor difference of cubes, I do little parenthesis, big parenthesis. What are my signs? Same, change, plus. So minus, plus, plus. What goes in the first parenthesis? Okay, so what cubed gives you 64x cubed? 4x. What gives you 1? 1. Now I use that to fill in the second parentheses, right? Okay. We're in this one right now. Go back to that you wrote down over here. The sum and difference of cubes. It's always same, change, plus from whatever you start with. Yeah. Well, whatever it starts with. So if this started with guys, shh, even if everybody whispers, it's too much in here with this many people. Okay, Harris. If I start with minus, then I start with minus here. That's my same. And then I change. Yeah, don't look at the bottom yet. We're on just the top of the fraction right now. Sorry. Hi. Harris, I've missed you so much. You're going to have to come up here and sit with me. We haven't looked at the bottom. All right. Everybody listen. Shh. I'm losing you. Come back to me. Baby, come back. What, Harris? Okay, but listen. Last year, Harris was sitting in the very back row in the last seat. But this year, Harris. All right. I'm going to use that first parentheses to fill in the second parentheses, okay? So square the first. What is 4x squared? 16x squared. Don't forget, yeah, a lot of people do. Don't forget to square the coefficient too. Multiply them together in the middle, ignoring signs. So 4x, and what's the end? 1. All right, look. If it wasn't a 1 in the first one, you would square up and in. Yes. So yeah, we multiplied 4x and 1, that's why we have 4x. Right. Okay. Harris. All right, guys, stay with me. This is just for you, buddy. If I had to factor this, Harris, do you recognize this thing a difference? In pink. This is just, I'm just trying to help Harris understand what this is, what the difference of cubes is. Do you recognize that being a difference of cubes? Difference means what? In math, if I say the difference of two things, what am I telling you? Perfect cube means times itself 3 times, yes? Is there a number that multiplies by itself 3 times? What? 2. Okay. What times itself 3 times might give you 27? No. I said 3. Okay. So this is a difference of 2 cubes because 2x to the third power is 8x cubed, and 3 to the third power is 27. So I could factor this, little parenthesis, big parenthesis. What are the signs going to look like inside? Minus. Okay. First parenthesis. What did you multiply 3 times to give you that first term? 2 what? 2x. What did you multiply 3 times to give you that second term? 3. take these numbers and use them to fill this in. Square this one. What's 2x times 2x? 4x squared. What's 3 times 3? 9. Multiply them together. That's what goes in the middle.
Okay, hold on.
I have completely factored the top, yes?
Yeah.
All right. Now the bottom. Is it a special pattern? Nope. I need to... Don't say that, Armando. Slash it. Oh, my dear. Okay. All right, Harris, you ready? Can I take out a GCF? No. What's in pink? No GCF, right? Yeah.
Oh, no.
Multiply the first and the last together and you get what? 12x squared. Give me two things that multiply to 12x squared, but add to negative 13x. Yes. Are y'all with me? Okay. This is going to be, stay with me. Minus x minus 12x plus 3. All I did was rewrote 13 as 1 and 12. Okay. Now I slash it. So slash method is only for quadratics or quadratic form. We got to quadratic form a little bit later. If the first degree, remember the degree is the biggest exponent, is even, 2, 4, 6, 8. The middle term is half of that. So if that was 8, the middle would have to be 4, and the last has to be a constant, then you can slash it. So she asked, could you always use slash? Is that what you always use if it's not a pattern? And it depends. Whenever we get into polynomials above a quadratic, so for quadratics, yes, you can always slash a quadratic. When we get in a little bit bigger to polynomials, in order to be able to slash, it has to be, the first exponent has to be even, the middle has to be half of that, and the last a constant in order to slash it. You remember? Like if you started with an exponent of 8, the middle would need to be an exponent of 4, and then a constant on it. The exponent. Okay, so let's look at it. These are confusing with the signs when the middle sign is minus. Anytime you throw minuses in there, it gets confusing. All right, look at the first two. What can I take out of the first two? X. What's left? 4x minus 1. I want to take out the x as well, right? All right, so the middle sign always stays, and in this case, it's a minus, which makes my heart hurt because it's a little bit harder, right, whenever it's minus, but that's okay. It just means my last sign's going to change. All right, so what can I take out of the last two? A 3. When I take that 3 out, what's left? 4x. I changed that to minus because of the negative, and then I took out a 3, so I had to hold the place with a 1. If you've done it correctly, the parentheses have to match, right? When they do, then you've got 4x minus 1 times. Yes. Okay, all that work, and we're not done. Doesn't matter. Because multiplication is commutative, so the order doesn't matter. All right. So now I change that. Now I can cancel things out. It took all that to get to the point of where I could cancel out. Notice these parentheses are the same, and so they can cancel. So simplified for this is going to be, that's exactly right. Nope, if one of them didn't cancel, and that's a good question, then it's already simplified and you couldn't simplify it any further. You just leave it. Basically, what you're doing is you're taking something like if you had a fraction, if we had that 15 over 20 or whatever it was, if you wrote it, remember how in like, I don't know what grade you did it, where you did like the factor trees where you said, you broke it down prime factorization, like this is 3 times 5, and this is 2 times 2 times 5. So only prime numbers, and then you can cancel. It's kind of the same thing. So if you get it broken down into its factored pieces and nothing cancels, then it's already simplified. It's already prime. You never did that? Bless you. You never took a number and said, okay, this is 10 times 2. I can't break 2 down, so this is 5 and 2. So the factorization would be 5 times 2 times 2. All right. Let's do another. This one's for you.
No, we do. Who asked that?
Yeah.
Oh no, please let's not start.
I'm not sure.
Wait, is that? Oh, this is on our own? Yeah. Wait, what?
You can use one. I will start restricting some calculator usage in here a little bit later. Because remember, we're getting ready for calculus, and calculus has half the exam is calculator and the other half's non-calculator. There's nothing that it would take you that long. She's brave. I'm going to take of the top, I'm going to take out a 12n. It's going to leave me with n minus 4. Most of you have got to that point, right? On the bottom, I'm going to take out an 18n squared. What's left when I take that out? 16 minus. Now, I do see something I could cancel out right now, but before I do, I always want to factor completely. Okay? So this is where things get a little sticky. So stay with me for a second. Do you notice? Do you notice that this set of parentheses on the bottom is a difference of 2 squares? Just because the variable does not come first does not mean it still doesn't satisfy that formula. So whenever I factor it, I can do 4 minus n, 4 plus n. Now here's where, whenever I said it gets sticky, here's where it really gets sticky. Because I'm ready to start canceling things out, right? But when I look at this, I go, but wait. Okay, this is an easy simplify, yes? I can divide them both by what? 6n, right? And so that would leave me, I tend to draw a fraction so I can just be working here. That would leave me with a 2n up top, nope, just a 2 up top and a 3n on the bottom. Yes? I'm going too fast? Okay. That's okay. Tell me when you're caught up.
What did you do to get to the 2?
So I divided both of these.
By 6.
Or if you think about it the way we did before, 12n over 18n squared is like 6 times 2 times n. And this is like 6 times 3 times n times n. And so the 6 is canceled and one of the n's canceled. It's just taken out, yeah. It's not going to help you simplify this one if you do that right. But you could, but it's not going to help us simplify. Right. But let me show you this other one. All right, listen. This might be something you haven't seen before. I'm not real sure. I feel like we did it. Okay. As you look at this, you might be inclined to think, yeah, but look, all these n's and 4's, surely something cancels, right? But as you look, n minus 4, I don't have an n minus 4 to cancel it. So you might want to just leave it. But I'm never going to have these two look the same, right? But this one, if you notice, the n is positive, the 4 is negative. In this one, it's just flip-flopped, agreed? So what if I took a negative 1 out of one of them? So in other words, could I say that 4 minus n is the same thing as negative 1 times negative 4 plus n, which is the same thing as negative 1 times n minus 4. Would you agree with that? Right. But if it's flip-flop and every sign is completely opposite, that's the key. Every sign has to be completely opposite. Then you can cancel it and replace it with a negative 1. Every sign is opposite. So the n is positive, the n is negative. The 4 is negative, the 4 is positive. Okay? Every sign is completely opposite. If that happens, it doesn't matter what you're looking at. If that ever happens, if I had x squared minus 3x plus 2 over negative x squared plus 3x minus 2, that's just going to give me negative 1. If every single sign is opposite. Does that make sense? Okay, so that's essentially what I'm going to do here. I'm going to cancel these out, but it's going to be held with a negative. It doesn't matter if you put it on the top or the bottom, but don't put it on both. But it's just really making my fraction negative. Yes, you can still take the 6. So my answer here would be negative 2 over 3n times n plus 4 or 4 plus n. It doesn't matter. I can add in either direction. So yes, but you would have had another step in simplifying whenever you did that. So if you got the 3n out, then you'd have to come back through and get a 2 out as well.
And now I'm at, I don't know what to do now. I divided the 2, and then I did the, I made this into 3n.
It's just giving you that extra step there if you don't take the biggest out first. It's not wrong, it's just more work. All right, let's multiply and divide, and then I'll stop because multiply and divide is pretty easy. All right. Technically, we're doing half this lesson today. Multiply divide takes us through half. 11:10 we leave, but we also have enrichment. One of the classes I got to rationals, one class I didn't, and I don't remember which one I got to it with and which I didn't. Simplifying. This is just simplifying. We will use simplify to do everything. So once we multiply and divide, then we simplify. Once we add and subtract, then we simplify. Once we solve the equation, then we simplify. Now, I put multiply and divide together because division is multiplying. Right? What?
Yeah.
Wait, what? Is it? Basically, if I had 1/2 divided by 2/3, that's the same thing as 1/2 times 3/2. Division is multiplication, right? Just like subtraction is addition, it's just the addition of a negative. Division is multiplication, it's just the multiplication of the reciprocal. So if you remember that, you really only have to learn multiplication because you'll have, right? So we're going to keep that in mind as we go through this, okay? Y'all ready? Yes, Miss McGee, we're ready. Did y'all know we were doing all this today?
No.
But we already know each other. Oh, my algebra 2? To divide, the first thing I'm going to do whenever I see division is I'm going to rewrite the problem as a multiplication problem, period. So it's going to be x squared minus 10x minus 24 over x cubed plus 2x squared times. Dang. All right. And now, every single thing I'm going to factor. Factoring is the key to rational expression. Okay? Period. You have to be able to factor. I'm going to look at even if it's just taking out a GCF. Because I cannot start canceling things out until every plus or minus is in parentheses. Period. Okay? Now, when you multiply fractions, remember, multiplying fractions, top times top, bottom times bottom. It's straight across. In fact, a lot of times whenever I get these, I will just come in and say, okay, this is one big fraction because I'm multiplying this times this times this times this. That's all I'm doing, right? But I'm going to write it in factor form. So here we go. Let's factor each and every one of them. Are y'all ready? This initially because I also don't teach it to you initially. I wait a little bit. But because this leading coefficient is 1, I can shortcut this in my factoring, meaning I don't have to go through all the steps of slashing, right? If it's 1, then whatever multiplies to the last and adds to the middle are my two factors. In other words, what multiplies to negative 24 but adds to negative 10? Negative 12 and positive 2. Yes? Negative 24x squared, negative 12, and positive 2. So the top factors, x minus 12, x plus 2. If you don't remember how to do that shortcut, go through and slash it, okay? Once you hit pre-cal, we shortcut a lot more, but if you still need that slashing step, go through and do it, okay? But when that leading coefficient is 1, that's an easy factor for us, okay? And we do that because on the calculus exam, it's timed, and so we have to start learning to do things a lot quicker, and shortcuts like that save a lot of time. All right. So x minus 12, x plus 2. On the bottom, what can I do? Take out an x squared. That's exactly right. If I take out x squared, what is left? X plus 2. If you want to cancel that out now, you can. I tend to go ahead and do the whole fraction, both of them, and then I start canceling out top and bottom, but whatever you want to do. All right, top of the second fraction, what can I do? What's left? X minus 4. On the bottom, can I shortcut that one? What multiplies to 48 but adds to negative 16? -4 and -12. So x minus 4, x minus 12. Everything is being multiplied now, right? Every plus or minus is in the middle of a parenthesis. Do we all see that? That's how you know you can start canceling, all right? This is one big fraction because I'm multiplying. Start canceling. This is the fun part. X plus 2. What else cancels? X minus 4. Anything else? X minus 12. Anything else? Sure? You can take out an X. All right, how did I get what? What multiplies to 48x squared but adds to -16x? So -12 and -4. It was a shortcut. Yeah. Say that again now, the what? So it's this X. Well, it was here, but it canceled with this because there was 2 X's in the bottom. Yeah.